Hello everyone, myself Dr. Deepika Seni, Associate Professor, Lloyd Institute of Management and Technology. Today I am going to present Unit 4 of Medicinal Chemistry 1 course code BP402T that includes drugs acting on central nervous system. The first subchapter in that unit is sedative and hypnotic. So today start with sedative and hypnotic. First of all, what are sedatives and hypnotics? These are drugs that will depress central nervous system, means that will reduce any kind of excitement, tension, and that will lead to relaxation in central nervous system. When we differentiate sedatives and hypnotics, these both are CNS depressant. The only difference is hypnotic will induce drowsiness and that will produce sleep. But the point to be noted, the sleep is similar to the natural sleep, means that the patient, the recipient can be aroused in a normal manner. Though sedative and hypnotic activity, it is dose dependent activity, means all sedative, hypnotic and general anesthetics, they depresses central nervous system. They cause depression in the central nervous system and decreases the activity of central nervous system, moderate the excitement. The observed effect of these drugs depends on dose. Just like given small doses, that will cause sedation. Sedation means the calmness that will moderate the excitement in the patient. When a patient is administered with the medium dose, that will lead to hypnosis, means drowsiness will get started and leads to sleep. But the larger dose, these cause surgical anesthesia, means they can be used as general anesthetics. Further, these sedative and hypnotics, they have been classified as in different categories. One is benzodiazepine, another one is barbiturates and miscellaneous agents. In these miscellaneous agents, though we have amides and aldehydes, so we will discuss it one by one. So the first category is benzodiazepine. Benzodiazepine, as the name suggests, they are fusion of benzene and diazepine ring. Fusion of benzene and diazepines. First we will draw a benzene ring and apart from that a diazepine. First we will understand what is diazepine. As the name suggests, di means two, aza means nitrogen and apine. Apine is a suffix that is used when there is 7-membered ring. It's 7-membered ring. So now the benzene ring is fused with a 7-membered ring that contains 2 nitrogen atom. Here we can see this is the benzene ring and this is diazepine ring. So further, benzodiazepine, they act as sedative and hypnotic by the enhancement of effect of GABA. GABA is gamma amino butyric acid. Its effect at GABA receptor that results in sedative, the calmness, the sleep inducing property and the anti-anxiety, anti-convulsant and even the muscle relaxant property. So benzodiazepines can be used as all of these category of drugs by the action of benzodiazepine on GABA receptor. Then there are different types of benzodiazepines. Some are long acting depending on their half-life depending on their drug elimination, metabolism, or that includes metabolism as well as kidney filtration. So, long acting, that half-life is more than 24 hours, that stays for 1 day. Example is diazepam and nitrazepam. Some are intermediate acting. Intermediate acting means almost 12 to 24 hours, like alprazolam, lorazepam, and some are short acting, that stays in body almost 1 to 12 hours, like triazolam. These are the structural examples of benzodiazepine. Before starting it, we should know the naming of benzodiazepine by numbering its ring. Like just we have 2 nitrogen rings, so we must get started with a nitrogen atom. So, we have numbered this nitrogen 1, then this is 1, 2, 3, 4. One nitrogen is at first position and next nitrogen is at fourth position, then fifth. Now, what will you see? We have skipped this fusion phase. We will not give number to this fusion phase. Then 5, then this is 6, this is 7, 8, 9 and so on. This can be given as 10 and 11. Now, what we have did? We did, this is given as 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, to show the substitution at the substituent benzene ring. This is not a main ring, this itself is a substituent at position number 5, but to show the substituent at this benzene ring, we have given the numbering of 1 dash, 2 dash, 3 dash, 4 dash, 5 dash and 6 dash. So, now here we can R1, R1 means at position 1 any substituent at position number 1, then position number 2, position number 3, then we have given position number 7 and position number 2 dash means with respect to the substituted benzene ring. In the case of diazepam, what we have seen, like this nitrogen is substituted with a methyl CH3. Here is a carbonyl group R3. Here is no substitution is attached, simple hydrogen. Then at 7 position there is a chlorine group and R2 dash position there is also no substitution. So, in this manner we can identify, we can structurally divide it into different examples of benzodiazepine. Similarly, oxazepam, lorazepam and chlorazepate. So, these are the structural examples of benzodiazepine. There are some more examples like alprazolam, one of the most common constituent of Alprex, that is known as sleeping pill, and diazoepoxide zolpidem. So, these are the example of benzodiazepines. Now, the mechanism of action of benzodiazepine, how will they act? So, they have positive allosteric effect on GABA receptor and they will stimulate the pharmacological action of GABA, that is main inhibitory neurotransmitter in CNS. Basically, CNS is depressed by GABA and GABA has depressive action on CNS. What the benzodiazepine will enhance the action of GABA. Okay, and the second mechanism of action is they also attach and directly block acetylcholine, that is in the hippocampus. And what is hippocampus? Hippocampus is a place where the memories, what is going on with us, that is being stored and processed. So, one of the drug, that is flunitrazepam, also known as date rape drug, that actually works. So what happens is the flunitrazepam that will get attached to the acetylcholine receptor and block the acetylcholine receptor, so that that will cause amnesia. This amnesia is loss of memory, that leads to loss of memory. Because of that, victim could not recognize the culprit. So this is the another mechanism of action that benzodiazepines follow. Here we can clearly see how benzodiazepines work on allosteric side. For example, this has been shown, like the chlorine, the receptor is empty. Receptor is empty means there is no GABA at this site, so there is no entry of chlorine right now. But after the addition of when GABA is attached to its receptor, there is influx of chlorine, and we can clearly see when benzodiazepine is attached at the allosteric site, it is not a competition, that a benzodiazepine will not replace GABA. GABA is situated at its own place. Now benzodiazepine will get attached to the another site and will act as a agonist, will act as a supporter for the GABA. That will increase. You can see there are more number of chlorine here, and these chlorine, this binding, this opening of chlorine channel, chloride channel, that leads to hyperpolarization of cell, and that also leads to depression in the central nervous system. So this happens when benzodiazepine is attached to this receptor. This tendency of depressing central nervous system get increased. So now we will talk about structure activity relationship of benzodiazepine. First of all, when we talk about this structure activity relationship, we have certain sites to act on. Like we have 7-membered imino ring, that is B. We have 2 rings, one A is benzene and B that is diazepine ring. So we have to focus on this 7-membered ring. That this 7-membered ring, it's essential for the activity. When we talk about the binding of benzodiazepine at the GABA receptor, then this 7-membered ring is an essential component of benzodiazepine. Apart from that, we have carbonyl at position number 2. As we have seen, we have replaced this R2 with O in case of diazepam. So this carbonyl group and even the double bond like this between the nitrogen and the 5th carbon atom, that double bond N4 and C5, they are also vital for the binding at the receptor. Suppose if we shift this double bond to this place, shifting of the double bond between carbon number 3 and nitrogen number 4, that will decreases the activity, that will lead to decrease in the activity. Further, next one is position number 7 at benzene ring. When we substitute this position with an electronegative element, any electronegative element that is required for the activity, more is the electronegativity, higher will be the electronegative property is there, higher will be the activity. So more is the electronegativity of the atom, higher will be the activity. Next, when we talk about this phenyl ring, so a phenyl ring at position number 5, that promotes the activity. But when this phenyl group is 2 dash, 6 dash or both, means at the ortho position, either 1, 2 dash or 6 dash or both 2 dash and 6 dash, that will lead to increase in sedative hypnotic activity. So, when we substitute this benzene substituent with at position 2 dash and 6 dash, that will lead to more active CNS depressants. Further, at position number 3, this position was unsubstituted in case of diazepam. Alkyl substitution at position number 3, that will decrease the activity except OH. You can try any substitution at position number 3, that will decrease the CNS activity apart from OH group. This hydroxyl group substitution leads to increase in activity. Compounds without 3-hydroxy group are non-polar and usually having longer half-life. So, this is a concept, like those which do not contain any OH group at position number 3, they will considered as non-polar and that will have longer half-life. Though which having hydroxy group at the same place, that will have short half-life because of the conjugation that will take place with the hydroxy group. The next one is synthesis of diazepam. So, this is one of the most important candidate of benzodiazepine category. So, in case of synthesis of diazepam, we have to consider the 2-amino 5-chlorobenzophenone. So, first we will draw a benzophenone. This is benzophenone. 2 benzene rings that are connected with the carbonyl group. So, this is benzophenone, and what we did, like 2 amino and 5 chloro. So, this is the first position to which carbonyl is attached. So, second position, here we have NH2, 1, 2, 3, 4, 5 and 6. And at position number 5 we have chloro. So, this is chloro. So, this nomenclature is clear, like it is 2 amino 5 chloro benzophenone. When we react this with ethyl 2 amino acetate, so first we will draw acetate, it's CH, it's CH3, but we will take CH2 because it's substituted, C double bond O, and it's ethyl. So, here it is C2H5, but at its ethyl 2 amino acetate, its position number 1, this is position number 2. So, it is substituted with a amine substituent. So, it's ethyl 2 amino acetate, this is ethyl 2 amino acetate. So, we have reacted 2 amino 5 chlorobenzophenone plus ethyl 2 amino acetate. When we react these two, that will lead to fusion of ring and 7 chloro 1,3 dihydro 5 phenyl 1,4 benzodiazepine 2-one is formed. So, let us start its numbering 1, 2, 3, 4, 5, 6, 7, 8, 9. So, first is 7 chloro. At position number 7, there is chloro, 7 chloro 1,3 dihydro, 1,3 dihydro, 5 phenyl, fifth position pe there is a phenyl substitution, 1,4 benzodiazepine, 1 or 4th position pe we have 2 nitrogen atoms with carbonyl at the second position. So, 7 chloro 1,3 dihydro 5 phenyl 2H 1,4 benzodiazepine 2-one is formed. Now, after the effect of dimethyl sulfate is SO4 by substitution of with 2-methyl group, that will lead to methylation of active nitrogen at position number 1. So, this will form NCH3 and the formation of diazepam. So, this is about synthesis of diazepam. In next lecture, we will discuss about the all other categories of sedatives and hypnotics. Thank you. So, this is all about benzodiazepine category. Let's revise it once again. So, first the benzodiazepines. Benzodiazepines, as I have told earlier, it is a combination of fusion of benzene and diazepine ring. Next, they will have an allosteric effect on GABA. GABA means they will increase the property, they will increase the activity of GABA. That will result into sedative activity, hypnotic activity, anti-anxiety activity, anti-convulsant activity, as well as muscle relaxant property of benzodiazepine. There are several different types of benzodiazepine: long acting, intermediate acting, short acting, on the basis of their half life, that they stay, how much time they spend in the body, like before the drug elimination, either through the metabolism or through the kidney filtration. There are several structural examples of benzodiazepines like diazepam, oxazepam, lorazepam and clorazepate. There are several other structural examples, and then the mechanism of action of benzodiazepines, as we have discussed, they have positive allosteric effect on GABA receptor, means when there is no GABA at this receptor, the calcium channel is blocked, is closed. After the attachment of GABA, the channel will open, and that will lead to hyperpolarization of cell, and that ultimately leads to depression in central nervous system. And when we connect, when the benzodiazepine binds at its allosteric site, so after the binding of this benzodiazepine, that will enhance the activity of GABA at its receptor. Here we can clearly see, like initially only one chloride ion was influxed, but now it has increased to 3. So, in this manner, benzodiazepine enhance the activity of GABA. So, there is structure activity relationship. First of all, this 7-membered ring, it is essential. Second, this carbonyl at position number 2, it is also mandatory for the benzodiazepine activity as sedative hypnotic. Further, the double bond between the nitrogen number 4 and carbon number 5, it is also essential. If we try to shift its position, that will lead to decrease in the activity. Further, any electronegative substituent at position number 7 will serve the purpose, that will increase the activity. When we talk about this phenyl ring at position number 5, and the further substitution at position number 2 dash and 6 dash is highly encouraged. When we talk about the alkyl substitution at this position, that does not give satisfactory results. So, we should not substituted the position number 3 apart from a hydroxyl group, as the position at the substitution with the hydroxyl group, that will lead to the polar compounds, and that will have a shorter half life. Further, the synthesis of diazepam, the 2-amino 5-chlorobenzophenone, that is being reacted with ethyl 2-amino acetate. When these two compounds reacts, that will lead to the formation of 7-chloro-1,3-dihydro-5-phenyl 2H14-benzodiazepine 2-one. With further addition of dimethyl sulfate, there is formation of diazepam. So, this is one of the most important synthesis in sedative and hypnotic. In the next lecture, we will do the further classification of benzodiazepine, including other categories. Thank you so much.